Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak Nemani and this is Daily Quant with Deepak. Hi all, welcome back to day 83 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from quantitative aptitude. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. And most importantly, keep a note of time on how much time you are taking to solve each question. And if you find this video helpful, like the video, share this video with your friends, and most importantly, subscribe to this channel so that we can help you with your CAT and other MBA entrance exams preparation. Right. Now, in case if you want to attempt these 5 questions in the form of a test, you can log into our portal, the gurukul.org.in. The link is already in the description. Now, once you enroll to that course, 100 days race to CAT, you'll get access to a course which has 3 sections, Quant, LRD, and VRs. We will be uploading 100 tests in each section. So, on a whole, you'll be getting 300 tests to practice on all the 3 sections, which accounts to nearly 1500 questions, which is a good amount of practice for your CAT preparation. And without any further delay, let's get started with the first question. If the diagonals of a rhombus of side 15 centimeters are in the ratio 3:4, find the area of the rhombus. Right. Now we know that rhombus is a parallelogram in which all the 4 sides are equal. And the side is given to be 15 centimeters, and we are also given with the ratio of diagonals. We are asked to find the area of the rhombus. Area of the rhombus is nothing but half into d1 into d2. So to find the area of the rhombus, we should be finding the lengths of the diagonals, and we are given that the diagonals are in the ratio 3:4. Now let me consider this part to be 3x. So this part becomes 3x. This part will be 4x since they are in the ratio 3:4, and this part will be 4x. Now observe, ratio of these two sides is 3:4 and this is 15 units in length. So can we use Pythagoras triplets? Yes, 3, 4, and this has to be 5x. Right, now 5x is equal to 15. What is the value of x? 3. So length of this part becomes 9, length of this part becomes 12. Now if this is 9, what is the length of the diagonal? 18. So half into 18 into, now if this is 12, what will be the length of the diagonal? 24. Half into 18 into 24. Right, so 2 12s, 18 into 10 is 180 plus 36, 216 square units should be the area of that rhombus. Now coming to the second question. The price of a product is P. A shopkeeper raises its price by X% and then offers a discount of Y% on the raised price. The discounted price again becomes P. If Y is the difference between X and Y, then find X, right? So now we have a percentage increase and then successive percentage decrease, so that I'll get to use the successive percentage change formula here, right? So X increase and Y decrease. So X minus Y minus XY by 100. And what is the resultant percentage because of these two percentage changes? 0. Right. This is 0. And if the difference between X and Y is Y, right? So this is Y. So Y minus XY by 100 is equal to 0, right? So I can write this as Y into 1 minus X by 100 is equal to 0. Now this will be 0 when Y is equal to 0, right? Now Y cannot be 0 because there is some reduction, there is some increase, and there is some decrease. So this should be 0. 1 minus X by 100 is equal to 0. So X by 100 should be 1, or X is equal to 100%. And that should be the answer to this question. Now coming to the third question. A mixture comprises water and liquids A and B. The volume of water is 1/3 of the total mixture, and the volumes of liquids A and B are in the ratio 5:3. To remove the water, the mixture is passed through a porous medium which completely absorbs the water and partially absorbs the liquid A. So there will not be any change in the volume of liquid B. Altogether, this porous medium absorbs 200 ml of the initial mixture, right? So that has both water and liquid A. If the ratio of volume of liquids A and B in the residual concentrated mixture becomes 7:9, then find the volume of water absorbed by the porous medium in ml, right? So we have water liquid A and liquid B. Right. Now the volume of water is 1/3 of the total mixture. Okay. So these two components, they form 2/3 of the mixture and water forms 1/3 of the mixture. Now they are in the ratio 5:3. So if I consider that the volume of liquid A is 5x ml, volume of liquid B becomes 3x ml, right? So together they form 8x ml, which is nothing but 2/3 of the total mixture. If 2/3 is 8x, 1/3 will be 4x, right? So what is the total volume? 4x plus 5x plus 3x, 12x ml, right? Now what happened? Uh, Altogether, this porous medium absorbs 200 ml of initial mixture, right? So when this liquid is passed through porous medium, this 4x uh, ml or 4x liters or 4x volume of water is absorbed. In addition to that, right? So some part of A is also absorbed, right? So there will not be change in the volume of liquid B, right? So because of that, the ratio of liquids A and B in the residual concentrated mixture becomes 7:9. Okay, 7:9, right? Now if I consider 9 parts is equal to 3x, right? So if 9 parts is equal to 3x, one part will be equal to x by 3, 3x by 9, which is x by 3, and 7 parts will be equal to 7x by 3, right? So if 9 parts is equal to 3x, 7 parts will be equal to 7x by 3. Now, initially the volume was 5x, now that has become 7x by 3. Why? Because some amount of liquid A is being absorbed by that porous medium, right? So, how much was absorbed? 5x minus 7x by 3, which is nothing but 8x by 3. So, 8x by 3 ml of liquid A is absorbed in addition to what? In addition to water, right? So, 4x amount of water plus amount of liquid A absorbed is given to be 200 ml, right? Now 4x into 3, 12x, 12x plus 8x, 20x, 20x by 3 is equal to 200 ml, or 20 tens 200, then x is equal to 30 ml. So we have the value of x, but what was asked in the question? We are asked to find the volume of water absorbed, right? So what did we consider the volume of water to be? 4x. So 4 into 30, 120 ml becomes the answer to this question. Now coming to the fourth question, a coin of radius 3 centimeters is randomly dropped on a square floor full of square shaped tiles of side 10 centimeters each. What is the probability that the coin will land completely within a tile? In other words, the coin should not cross the edge of any tile. So that means coin should not be like this, or coin should not be like this. The worst case scenario is coin just touching the side of the tile, right? No part of the coin should be outside that tile, right? Now let me draw a line which is 3 centimeters away from the side of the tile. Now if I consider the center of that coin to be here, right? So the radius of that coin is 3 centimeters, so I can say that some part of that coin will be outside that tile, right? Now when can we have the tile completely inside that tile, sorry, coin completely inside that tile, right? For example, if I have a center here, right? So I can say that the coin will be completely inside that tile, because the center is more than 3 centimeters away from the side of the square, right? Now at the same time it should be at least 3 centimeters away from this side, and this side as well, right? So let us divide the tile into some parts. Okay, let me draw a line and let this be 3 centimeters away from the left side, and similarly 3 centimeters away from the right side, and 3 centimeters away from top, and 3 centimeters away from bottom. Now if we have the center of the coin lying in this square, right, the coin will be completely inside the tile, right? For example, if we have a coin here, the center of the coin here, the position of the coin will be like this. right? So no part of the coin will be outside the tile. When if we have the center of the coin lying either on or inside this square, right? Now let's find the side of that square, right? So total length is given to be 10. We know that this should be 3, this should be 3, this should be 3, this should be 3, and this should be 3, this is 3, this is 3. Now total is 10, 3 plus 3 is 6. So this length should be, sorry, my bad, 4 units, and similarly this side should also be 4 units. Now if we can have the center of the coin lying on or in this square, that means in an area of 16 centimeters square, out of what was the area of the tile, 100 centimeters square, I can say that the coin will always be inside the tile, right? So 16 by 100, 0.16, and that should be the answer to this question. Now coming to the fifth question. It takes 2 liters to paint the surface of a solid sphere. If this solid sphere is sliced into 4 identical pieces, how many liters will be required to paint all the surfaces of these 4 pieces, right? Now let the radius of the sphere be r. So the total surface or the curved surface area of the sphere is 4 pi r square, right? Now to paint 4 pi r square units of area, right? So 2 liters of paint is consumed, right? Now what happened if this solid sphere is sliced into 4 identical parts? Now you have 4 identical parts. How many liters will be required to paint all the surfaces of these 4 pieces? So the curved surface and also the circular surfaces, right? Now if you take this piece or if you take this piece, now 1/4 of the total curved surface is there, and you have a quarter of circle here and quarter of circle here, right? Or you should be painting the total curved surface, which is 4 pi r square, plus now here if you rotate it like this, right? So you will be having a circular cross section here, right? Plus pi r square, and same circular cross section should be painted on this side, plus pi r square, plus similarly you have a circular cross section here, pi r square, plus you have a circular cross section here to be painted, so pi r square. Now you should be painting how much? 8 pi r square units of area, right? So if 4 pi r square units of area requires 2 liters of paint, 8 pi r square units of area will require 4 liters of paint. So the answer for this question becomes 4.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.